Welcome to our new podcast series called In the Mix. I am Wynn Darden. I'm the business manager for the Lumiflon FEVE fluoropolymer resins. The podcasts are all about choosing the right coating solutions, where we discuss with industry experts what influences their decision-making processes when it comes to specifying and using coatings. We'll delve into how experts develop their strategic planning approach to current structural and future market demands. In this episode, we'll talk with Ben Gillies, the sales manager for A&I Coatings in Moss Vale, New South Wales, Australia, so across the world. A&I has been making their Vitreflon fluoropolymer coatings based on Lumiflon resins for ultra-durable coatings. Their products have been used on bridges in the UK, high-rise residential towers in Sydney, sculptures in Melbourne, and stadiums in New Lambton, Australia. We'll try to see how the protective coating market in Australia differs from that in the US, and how Lumiflon resins enable A&I to supply durable coatings for use over there. Welcome, Ben. It's good to have you with us today.
Good to come on board.
Can you tell us a little bit about A&I Coatings, how it was founded, and how you started to use Lumiflon resins? I know you're involved in a lot of other coatings and coating systems as well.
Certainly. So, Ben Gillies, sales manager here at A&I Coatings. The company is a third-generation paint company founded by my grandfather. He was initially involved in coatings at a couple of other major coating manufacturers before branching out on his own. So he was head chemist at Taubman's. He worked at Balm Paints, which is British Australia lead manufacturers, which then became Dulux. So in 1989, we started manufacturing coatings. Prior to that, my father and my grandfather were coating applicators. So they were, I guess, hands-on, at the ugly end of the industry, sandblasting tanks, painting tanks, all sorts of applications. And we started manufacturing polyurethanes initially in 1989. So we were selling those fairly successfully, but we were having some issues with early fading, loss of gloss, just so assets weren't looking as good as they could for as long as they could. So my grandfather went looking for the most durable coating solution on the market, and that led him to Lumiflon. So in the year 2000, we released our first fluoropolymer coating product, which was Vitreflon 700. And that was initially used largely for compressed fibre cement facade panels, which was another one of our businesses also. So we made the paint and then applied it to facade panels, and then we could put a warranty that was 3 times longer than the traditional warranties we were putting on with polyurethane. So that's, I guess, essentially how we got into the fluoropolymer coating world, and I can say today without a moment's hesitation that it's certainly underpinned our success in the coating industry, and AGC leads the charge with fluoropolymer resins. We've never found a product as durable or as high quality as Lumiflon. Hope that answers your question.
It does. It's always interesting to hear how people get started in the industry, and I guess generationally, coatings has a way of just taking you in and getting you into the market. So you start to like it, and it's a unique area to be in. It's a lot of fun to do, I think.
Yeah, I think it's just on that. I think it's somewhat of an acquired taste.
Yeah.
As you grow up, I used to work here when I was coming out of school, or during school holidays, I should say. And yeah, I must admit, it didn't grab me back then, but I guess the more you get involved in it, the more there is to learn, the more interesting it gets. And it seems to follow a similar pattern with other smaller paint manufacturers that I know, that it just seems to go from generation to generation. So
it's great to see that. The big paint companies have kind of taken over everything. So it's nice to see entrepreneurial small companies who can move in the market quickly and introduce and sell a product like Vitreflon. And I think it does a lot of good, and reduces waste, environmentally sound. I think there's a lot of advantages to these durable coatings. So it's good to see younger people. I can say that now because I'm old, participating in the industry and helping to grow it. So that's great. What do you guys deal with in Australia and places like Australia and New Zealand as far as climate and weather and things like that that influences the choice of coatings down there?
Yeah, good question, Win. So it can be a challenge in Australia. We've got pretty much, I believe, every climate within Australia somewhere. So from down south, Tasmania, for example, is quite cold, but not necessarily any more corrosive, I guess, than other coastal areas. But then moving up to Melbourne, still fairly cold, which can be a challenge for application properties. So we need to formulate to make sure that coatings will still cure positively, for example, in low temperatures. And then moving further north, up to the top of Australia, say Cairns, Townsville area, it's very hot. So they hardly really have a winter. And again, that influences our formulation as well, because often for a lot of different paint manufacturers coatings, we say don't apply it if it's over 80% humidity, for example. But the reality is that in Townsville, Cairns area, it's hardly ever under that. So we need to make sure the coatings, number one, can be applied in a user-friendly manner right across Australia. And then in terms of actually selecting the coating system, we're a firm believer in using fluoropolymer for probably 90% of applications, because whether if it's in a coastal region, then it's proven itself time and time again to be more corrosion resistant because it reduces the ingress of corrosion initiators. Um, but when I say that, in Cairns, for example, we might have a coating system that's 350 microns total. So it might be 75 microns of zinc rich epoxy, it might be 200 microns of micaceous iron oxide epoxy, and then the fluoropolymer top coat. And that's a pretty bulletproof system. But then we might go somewhere really dry like Alice Springs or even Canberra, for example, and we would still recommend using a fluoropolymer, um, but just without the overall coating thickness. So we might just go 75 microns of zinc-rich epoxy and 75 microns of fluoropolymer. And the reason we would still stick with a fluoropolymer in those less corrosive areas is because it's just going to look better for longer. So in the middle of Australia, for example, the UV is still very harsh. So if you've got feature architectural steelwork, which is red or yellow or orange or even black, it's still going to fade quickly, even though it's away from the coast, away from, I guess, those corrosion initiators. So we generally change the underlying coatings to suit the corrosivity category. But as a general rule, where budget allows, we'll stick to fluoropolymer for the top coat
Okay.
99%
And
of
you
the time.
mentioned the fiber cement materials. So you got your company was making the fiber cement and supplying the coatings, or what was going on there?
Correct. So, well, we were purchasing the fiber cement from a fiber cement manufacturer, and then we were just supplying it to builders as a pre-finished facade cladding material.
Okay.
So, where you would typically see aluminium composite panel or 3 mil aluminium. I think you actually say aluminum over there. I haven't got used to
We
that
do, but
yet.
that's all right.
Yeah. So where you typically see that type of cladding is where we would have sold the compressed fiber cement cladding.
Okay.
So, and it's been very popular, and it's got a great brand out here. So it just gets specified time and time again, because it's been in the Australian market for almost 30 years. Initially with polyurethane, but then 100% of the production was switched out to use a fluoropolymer top coat, which was Vitreflon 700. So it's kind of the two companies went hand in hand.
Okay.
The A&I Coatings made the paint and supplied it to Vitreflon, which put it on the
Okay.
facade panels. And that was where a major portion of our fluoropolymer sales would have gone to in the early days. Now
Okay.
it's kind of flipped. The compressed fiber cement is, I guess, a much smaller percentage of our overall market.
Okay. Yeah, it's not widely used. It's mainly used over in the U.S. for residential construction, not so much as a facade on a building, but for houses primarily. So it is being used over here, but I think you guys use it a lot more over there than we do. And so you would supply for steel and for aluminum, I take it.
Yes, correct. Yeah, we do. We also supply for a range of other substrates. What we've really discovered over the years is you can use fluoropolymer coatings based on Lumiflon for almost any substrate. The difference is how you prime it, how you prepare the substrate, and how you prime it. So, yeah, it's our go-to top coat for steel, for concrete. So we've used it on concrete structures, um, fiberglass, glass reinforced concrete. Trying to think what other substrates. Yeah, obviously aluminium. So it's got a wide use area.
Yeah, very versatile material, I think. So, what's the specifying process in the markets down there? Is it you get an architect that for a new building, or how does that work down for you guys down there?
Yeah, basically, we try to go to the asset owner
Okay.
as step one, because often if we were to approach a builder, for example, they're not so invested in the long term durability because they do their job, they build the building according to the architect's specification. In essence, they don't see the benefit of a product that's going to last 60 years because they're just there to build buildings. So we try to sell it to the asset owner because they're the ones that are going to be wanting to save their budget moving forward. So typically for a bridge, for example, that would be local councils or government bodies. For the high-rise buildings or the stadiums, it would also be government bodies to a certain extent, but probably more the asset owner or wherever the budget, the maintenance budget is coming from, that is who we'd target. In Australia, the specifying process or the standards is where it starts to get a little bit tricky. So we're behind, I think, a good number of countries in where we're up to with specifying the best coating systems. So to flesh that out, our coating system standard is called AS2312. And what that does is details the different coating systems, their expected lifespans, um, and the different coating technologies. So, for example, it will in AS2312, it will say PUR5 is a coating system that will last 15 years in a C5 environment. And what that will consist of is an epoxy primer, an epoxy intermediate coat, and a polyurethane top coat. So there's currently no entry in AS2312 for fluoropolymers, which is something we're really trying to change. And to, I guess, put that into perspective, New Zealand has got its own fluoropolymer standard. UK has got its own fluoropolymer standard, so we sell a lot more fluoropolymer for bridges in the UK than in Australia, purely because we just don't have that standard there. And it's a bit of a challenge speaking to bureaucracies about getting it included, because one of the things they will typically ask for is, okay, show me where it's been done for 25 years to prove that we can say it's going to last 25 years. And that's a challenge because we've only had it in Australia for about 23 years. So it's a little bit difficult, but we're in it for the long game, and we're currently putting together a submission for the standards committee to include fluoropolymer, which will then see, I think, a significant uptake. But just to clarify, whenever you can sell it to the asset owner, they can often override the standards, which has been the case for a lot of projects to date.
How does the architect or engineering firm fit into that?
Yeah, good question. It's a hard sell because, well, it's an easy sell for us, but it's a more difficult sell because they can't reference a standard. So architects and engineers love referencing a standard. Um, so they will say use A&I Coatings system PUR5, which is a polyurethane. But when we try and flip that to FEVE, they say, well, what do I put on the specification? And so what we've got to say at the moment, if they're hard and fast on requiring a specification, is put in PUR5, but then in brackets say must be FEVE modified.
Ah, okay.
The problem is that can confuse the market. So it's a little bit tough. What we're trying to do is do an FEVE standard, so FEVE5 or FEVE4, depending on the builds. Once that's done, I think that'll be a major step in the right direction.
Yes. Yeah, it's big over here as well. We do quite well in the water tank market here, the elevated water tank market,
Yes.
primarily in the Midwest and in the South where they don't have mountains or anything to help with gravity helping the pumping issue. And the American Waterworks Association has it's actually a sentence within the specification that references fluoropolymer. And what
Right.
that does, it allows the engineer to basically take the responsibility off of his shoulders. And if anything happens or anything, he can point to the standard and say, "All I did was follow the standard."
Yes.
The other one, there's an ISO 12944 that I think has been used, and we have a newer standard here called Paint 47 that's from the SSPC, now the AMPP. So I'll probably have to email you those over to you so you can take a look at them and maybe help you write your standard over there. Yeah. So
Um, what about your standard for bridges, like for main roads, and is it Department of Transport over there? Does that have a dedicated fluoropolymer specification?
well, we're a little different. I don't know how it works down there, but over here we have 50 state departments of transportation. And then within those areas, you have bridge authorities that will run. For example, the Golden Gate Bridge is the Golden Gate Bridge Authority has been designated as the people who run that bridge and maintain the bridge.
Right.
Uh, we're also finding out it could go as diverse an area as a county. Counties own about 40% of the bridges here in the U.S. Now, not necessarily the monumental bridges that the big ones like the Golden Gate, but they do have a lot of steel bridges and they do need to be repainted. So we're kind of in the same boat here. Part of our we've been a little bit successful in California and in Florida in having materials written into the specification. But there are a lot of the state DOTs have joined these organizations that require testing in order to, passing a certain number of tests in order to be put onto the approved product list or the qualified products list, as they call them over here. And
Yes.
we're a resin supplier, so we really can't get anything approved over here. We rely on companies like A&I to submit their coating systems for approval. So it
Yes.
can be a little more difficult for us, I think, even than it is for you. We rely on our customers doing it, and of course that could be an expensive process. It could cost quite a bit of money to get these things tested.
Yeah.
Um, so, and in some cases, the engineers, the architect, the specifiers over here, it is a risk for them because if they write in the FEVE like you were talking about, there's a risk for them. If it doesn't do well, then that reflects badly on them.
Exactly.
Uh,
They get challenged as to why they moved away from the standard.
yep, exactly right. Yeah. So yeah, we kind of do the same thing here. It sounds to me like maybe the architects and engineers have more power here than they do down there to specify materials. We focus in that area on bringing architects on board with our materials and trying to get them to adopt them and keep them in the products that they specify.
Yes. Yep. Excellent. Yeah, it's probably with the Australian projects, it's probably I guess, the anything that's a government asset is where it gets a little bit difficult
Yes.
because they want to dot their I's and cross their T's. And if there's not a corresponding standard, they do get scared. We have had, I guess, a number of projects, a number of really, really significant projects where the product has just spoken for itself.
Yeah.
And they've said, look, this is a no-brainer. We've got to do this. We can't wait for the bureaucracy to catch up. So there is those scenarios, which is good when they come through. And to your point with testing, we had to have our products tested in the UK. So they've got a dedicated fluoropolymer specification and also a raft of testing which they need reported on that particular product. And then once that's been done, then your product, your formula is approved for use whenever the contractor or the asset owner chooses to do so. Which it's a long process initially, but I think it's a good process at the end of the day because it means that everyone has to test their products if they want to sell it. So you stand very little chance of getting a product that doesn't perform. So yeah, we find that's a pretty good way to do things.
And the fluoropolymers will shine in that process. They really will come through with that. Um,
100%.
Over here, it's important that you have more than one company that's actually manufacturing the coating. Many
Yeah,
government contracts can't be sole bid, or it's very difficult to get the contract to read that way. But we have been fortunate. A couple of the DOTs have made exceptions to their spec list and have specified our products. So we've had a couple of pretty big projects over here that have been very exciting for us on the bridge side, especially.
brilliant. Good to see.
Yeah. How did you get into the UK market? I hear you guys are painting a lot of bridges over there.
Yeah, so we first started with facades over there, mainly aluminium facades when the major aluminium cladding suppliers ran out of a particular colour or for some reason couldn't supply what the customer needed, and so then that's where we would step in with Vitreflon 700 and supply a coating which would be on par performance wise, on par or better, and in whatever colour they wanted, in whatever volume they wanted. So typically, I believe with coil coated aluminium panels, the minimum run for a custom colour might be 300 square metres, which can be a challenge on some multicoloured facades. So we were selling Vitreflon 700 wherever they wanted either less than 300 square metres or they ran out of a particular colour. And then that was when we realised the potential there was in bridge painting. Because in Australia, a lot of bridges get made out of concrete. We don't have a lot of architectural masterpieces like the Sydney Harbour Bridge. Whereas what we noticed in England, there is just a mind-boggling number of bridges which need a lot of maintenance. So I guess the other thing is they've been building bridges for a lot longer than Australia have. Australia's only been building them for a couple of 100 years at the max, and UK's been going for obviously a lot longer than that. So the size of the market was very enticing, and the amount of maintenance needed over there too. So once we, I guess, identified that opportunity, we had to then get the fluoropolymer specification reinstated. So it had actually been removed for some reason from the, I think it's called the Highways England Standards, but it was there in the background. So we had to work to get that reinstated. Once that was reinstated, we then had to get the coating systems tested, which took, from memory, it was around about 15 months. And then it went from there. It was a really slow burn because in the specification game, obviously, it takes a long time. But I think we're really seeing the fruits of that come through. There's a lot of landmark bridges over there that are being done with our fluoropolymer now. So good market being.
Yeah, it's very exciting when I see some of the projects you guys have been doing over there. It's really really interesting. Um, Ben, you mentioned the Vitreflon 700. Do you have other materials that you sell that say vary in flexibility or things like that? For example, a steel substrate might require a different coating than say a fiberglass substrate.
Yes. Yeah. So we do change the formulation depending on the requirement. So Vitreflon 700 is our oldest serving fluoropolymer. It was the very first one we released. We have projects out there now which are about 22 years old, which are going really well. Then for steel, though, what we really discovered or found was you need a high solids product to be competitive. So Vitreflon 700 is approximately 32% volume solids. We've got another product called Vitreflon 790, which is 62% volume solids. And what that means is just so much easier to apply. And if you over apply it slightly around cleats or complicated architectural steelwork, it's got a much reduced chance of sagging or running. And it also goes twice as far. So at the end of the day, it's more competitive for the applicator. And then we've developed a few others as well. So we've got Vitreflon 744, which is an anti-graffiti coating. So it's got a silicon additive in it, which means that the graffiti doesn't want to create an unbroken film over the top of it. It wants to bubble up like oil on water type thing. Then even more lately, we've developed a product called Vitreflon 795, which is we've developed for excellent scratch resistance and also excellent UV resistance. So where it typically gets used is on fiberglass substrates, and there's a very innovative company out here which has started manufacturing telegraph poles out of fiberglass,
Okay.
which is it's an incredible process to see. And there's so many advantages. So they don't rot like a timber pole will eventually. They don't rust like a steel pole will
Right.
eventually. The challenge with that particular product is the installers, which is the energy companies. They're used to handling timber telegraph poles, so they don't damage easily. They're very heavy. And with the Vitreflon 795, we had to develop it to withstand, I guess, the same installation procedures with
Right.
a fiberglass telegraph pole. So yeah, it's very versatile, and we use various different grades of Lumiflon depending on the properties we're trying to achieve. But easy to customize, yeah.
Okay. Are water-based coatings being used more in Australia now? There's a push here, I think, to some extent. Maybe not as loud as it was a couple of years ago. But is that? Do you see that over there as well?
To a certain extent, it's not as prevalent as you might expect. And I think that's because Australia still has reasonably lax VOC content
Okay.
requirements. So you can still use a polyurethane, for example, with 400 grams VOCs per litre.
Okay. All right.
Um, in addition, I think the other challenge is that a lot of the steel work, for example, is getting painted in a blast yard, and down here they're typically never heated. So if you try and apply a water-based two-pack coating
Got
at
it. Yeah.
8 degrees in Tasmania, it just doesn't want to dry out. So
right.
it really hasn't caught on. Where it does get used in a major way is for site application, but then typically those are single pack products.
Okay, all right. Yeah, they Caltrans had developed California Department of Transportation developed a water-based one component coating. They used it on some of the viaducts out in the San Francisco area, and they water-based because they don't want solvents, and they don't want to use 2K because of the isocyanate. Their own painters do a lot of the work, so it's not an outside contractor that specializes in application of 2K coatings. So they want something milder and easier to use for their customers.
Yeah, yep. Definitely makes it more simple being single pack.
Yep,
So would
yep.
that be based on something like FE 4400?
FE 4300, the Lumiflon FE
4300.
4300. Yep, in
Yep.
a blend typically with a standard acrylic resin. The acrylic improves the adhesion. Uh, the Lumiflon contributes the weatherability that they need to use it. Cautious because they don't want the price to be so high that the bridge engineer making the decision to paint the bridge and using which paint, they don't want him. They don't want the price to be so far out of line that he gets cold feet and says, "I don't want to pay that much for it." So all sorts of interesting things when you get into these DOTs. You want to supply them with the best that you can do, but sometimes you have to compromise and say, well, it's going to be a lot better than what you're using now, but it's not going to be the ultimate in protection like a 2K Lumiflon or Vitreflon material will be.
Yes.
So
Yeah. So a little bit of a compromise, but better than their
better
typical.
than the standard acrylic, yeah.
Yeah.
So
Yep.
Ben, when you guys do projects in the field, do you have qualified applicators? Do you train the contractors to use the material, or is it just pretty much who bids the projects?
As a general rule, it does depend on the project. So typically, we don't have a lot of control over who bids and who ends up winning it. However, if we've got some doubts as to their skill set, we will 100% offer training,
Okay.
but we'll also encourage third party inspection.
Okay.
And whether the asset owner pays for that or um, whether we do, typically the asset owner does.
Right.
But
Right.
it just means that you can be 100% sure that everything gets done properly and to our specification.
Do you see any new substrate trends? I know you'd mentioned fiberglass, and of course, for us, the fiber cement is an unusual substrate. But any newer ones or anything coming up that looks interesting?
Good question. We're selling, I guess, more and more for fiberglass and GRC,
Okay.
and I think that's going to continue to grow. So we've got a customer in Texas at the moment painting fiberglass for
Yep.
things like boardwalks, little, not reasonably small bridges, comparatively, but just marine structures, wherever there's going to be a benefit from the corrosion resistance fiberglass offers. I
Right.
think we're going to see that particular substrate grow because you only have to save one maintenance cycle and you've already paid for it. So we see that. We're doing a project in Melbourne at the moment, which is fiberglass panels, I guess architectural fiberglass panels, which are custom made and they attach to the side of a bridge. And that's going to be really one to look out for. It's about 35,000 square meters of fiberglass. Um,
Wow.
Apart from that, I think that's generally I guess, the newest materials we've been involved in. Do you see new materials surfacing in the US?
I think you probably are seeing fiberglass being used more. We actually over here we supply materials that goes in for actually factory application for fiberglass windows,
Oh, yes.
and they of course, a lot of the windows we on the facade side, we powder supply a powder coating resin for a lot of the aluminum extrusions. So on these monumental buildings and things like that, the powder is getting quite popular because of the salt. There's no solvent, environmentally friendly, and things like that. But fiberglass windows are being used more and more. The problem with aluminum is that you have to thermally break it from the outside.
Right.
So usually you're putting polyamide or polyurethane foam in an area on the window to keep the cold from coming through the double pane glass. And with fiberglass and with urethane pultrusions, that's another area that's growing. You don't have to have that. They're insulated as they are. So you don't have to put all that extra hardware on there and go through the extra processing steps that you need to when you have to put the break in there for the cold.
Okay, very interesting. Another application you might be interested in, which has just come to mind, we now sell fluoropolymer coatings for swimming pools,
Oh yeah.
which is very interesting. We never realised that it was a good system for that until probably 6 or 7 years ago.
Uh-huh.
And that market was actually ripe for something improved to come along, because typically they've been using high solids epoxies
Yep.
in whatever color, whether it's a blue, but you get this horrible chalky fade line around the top of the pool.
Yeah.
Whereas with a fluoropolymer, above the waterline and below the waterline, there's no difference in color. So it's a very interesting application, and it's not something you could do with a polyurethane. So polyurethane, we found, will typically blister in that immersion scenario, but the fluoropolymer performs incredibly well. So we've supplied round about 1,000 pools now.
Oh wow.
With
Okay.
really, really good results.
Well,
so that's another interesting application.
You send some things over here, and you can make it 1,001 with my pool.
No worries. Done.
Okay. Ben Gillies, thanks so much for spending time with us on and talking about your coatings. We wish you a lot of success with them, and keep us in mind if you need some houses to paint in the U.S. or, like I said, the swimming pool to paint. We're more than happy to be the guinea pigs.
Fantastic. Thanks a lot, Win. Great to catch up. We'll be in touch.
Thank you for listening to our podcast, In the Mix. If you enjoyed this episode and you'd like to hear more, be sure to subscribe. To catch all the latest from Lumiflon, you can visit our website at lumiflonusa.com or follow us on Instagram, Twitter, and LinkedIn at LumiflonUSA. Thanks again. See you next time.